During Artemis II's return from the Moon, analysts tracking Orion noticed something. A small object near the spacecraft that did not behave the way passive debris should. Orion performed correction burns. The object stayed. And that's the part engineers are still discussing. One analyst reportedly became interested after the object appeared to remain visible even after Orion performed correction burns during the return phase. Not because the observations were impossible to explain, but because none of the explanations fit perfectly. The observations emerged during Orion's return from the Moon. At that point, the spacecraft was crossing cislunar space, where distances become difficult to process. Orion was moving through near vacuum almost 400,000 kilometers from Earth, inside one of NASA's most monitored flight profiles. And yet, a small object near Orion drew unusual attention because it seemed to remain there longer than analysts expected. For portions of the return flight, the object reportedly appeared to stay near the spacecraft instead of separating cleanly into deep space. Deep space missions regularly produce confusing observations. Ice crystals, detached fragments, reflections, and tiny particles illuminated under extreme sunlight can suddenly appear enormous against the blackness of space. According to later tracking discussions, the issue was not simply that an object appeared near Orion. The issue was how long the apparent alignment seemed to persist. Because passive debris does not normally maintain stable relative positioning once a spacecraft begins adjusting trajectory. Orion was not floating motionless in space. Outside the spacecraft, there was almost nothing. No atmosphere, no nearby traffic. Just Orion moving through blackness 400,000 kilometers from Earth, while analysts in Houston tried determining whether the alignment made sense. During the return journey, Orion performed multiple correction maneuvers. Even tiny velocity changes can alter relative spacing between objects traveling through deep space, which means that if the object were simply drifting debris, the alignment should eventually begin changing visibly. But according to some tracking discussions, that separation did not appear as clearly as analysts expected. Hours later, after another burn, analysts expected the object's apparent position to drift away from Orion. Instead, it still appeared nearby afterward. Not perfectly stationary, but persistent enough that analysts reviewed the footage frame by frame. The situation reportedly became more uncomfortable once analysts compared the object's apparent behavior across different phases of Orion's return profile. After maneuver windows, when independent motion should have become easier to identify, the object still appeared intermittently nearby in portions of the footage. The persistence was enough that some engineers reportedly continued revisiting the tracking discussions long after the return trajectory had already ended. One explanation involves perspective compression. Deep space creates deceptive visual conditions. An object much closer to Orion than it appears on camera could maintain apparent alignment far longer than intuition suggests through long focal length imaging systems against an empty background. Another possibility involves reflective particles traveling on similar vectors. A small fragment released with nearly matching velocity could appear stationary relative to Orion before divergence becomes obvious. Modern spacecraft do not see space the way human eyes do. Cameras aboard deep space missions rely on infrared systems, star tracking references, optical calibration, and automated image processing. Tiny anomalies inside those systems can produce effects that look physically meaningful before engineers understand them. Perspective compression helps explain apparent positioning, but it becomes weaker if the object remained visible through multiple maneuvers. Every new explanation seemed to solve one part of the observation while creating another question somewhere else. If the object was extremely close to Orion, perspective effects could explain why it appeared visually stable. But then analysts needed to explain why the apparent positioning still looked unusual after correction burns altered Orion's trajectory. If the object was farther away, that created a different issue entirely. Deep space distances are enormous. Maintaining repeated apparent alignment across maneuver phases becomes harder to dismiss as coincidence once observers begin reviewing the timing frame by frame. And this is why some engineers reportedly continued revisiting the tracking behavior long after the return sequence itself had already ended. The footage continued producing the same uncomfortable reaction. Something about the apparent behavior did not feel completely settled. Inside highly controlled missions, unresolved details tend to attract attention very quickly. Far from Earth, even tiny inconsistencies can quickly become systems, questions inside missions built around precision. Trajectory behavior is supposed to become more predictable as more data arrives, not less. Apollo astronauts occasionally reported lights or objects that later received technical explanations. On Apollo 11, Buzz Aldrin described observing a moving object outside the spacecraft, before mission analysis later suggested it may have been a detached panel from the Saturn V rocket. Space is visually deceptive in ways humans are not naturally prepared for. Distances disappear, reference points vanish. Tiny reflective objects can dominate a camera frame against complete darkness. And when spacecraft travel through nearly empty space, small observational inconsistencies become difficult to resolve with confidence. NASA, private aerospace companies, and international programs are preparing for sustained activity there, which means tracking accuracy and object identification are becoming serious engineering priorities. The Artemis missions represented the return of human deep space operations beyond low Earth orbit. Orion was built to operate using star trackers, optical navigation systems, inertial guidance, and communication through NASA's Deep Space Network. It is one of the most sophisticated flight systems ever constructed. That is why unresolved observations become powerful, not because they prove something extraordinary, but because highly controlled systems are expected to explain their environment cleanly. Maybe the apparent stability came from perspective effects interacting with Orion's trajectory. The discussion persisted because the observations occupied an uncomfortable space between explanation and uncertainty. Because in deep space, reality does not need to completely break in order to feel wrong. Sometimes all it takes is a small object continuing to appear where some analysts no longer expected it to remain. And for a brief period during Artemis II's return from the Moon, some analysts reviewing the tracking behavior were not fully confident that the observations behaved the way passive debris normally should.